here is the question. Let us write this thing. You see, this is a series, so uh, let us simplify this. So 1 by 2n summation j equals to 0 to n minus 2, 2 to the power 2j, and you see that this is nothing but a geometric series. So this will be 1 by 2n, and the first term is, if you put j equals to 0, this is going to be 1. So the first term is 1, and the common ratio is 4. So 4, and the number of terms, if you observe 0 to n minus 2, then the number of terms is n minus 1. So minus 1 by common ratio minus 1. So this becomes 1 by 2n, and here we can write 2 to the power 2n minus 2, because 4 can be written as 2 to the power 2, minus 1 by 3. So this again can be changed as 1 by 3, 2 to the power n minus 2, minus 1 by 2 to the power n. Now the second, that is this one. In the same way, this one can be written as 1 by 2n summation j equals to 0 to n minus 1, 2 to the power 2j. And this, you see 1 by 2n here, and again this is a geometric series with first term 1 and the common ratio being the same, but the number of terms in this time is n. From j equals to 0 to n minus 1, there are n terms, so 4 to the power n minus 1 by common ratio minus 1, and you have 1 by 3, and again this 4 to the power n can be written as 2 to the power 2n, and with this 2n, here will be 2 to the power n minus 1 by 2 to the power n. So our sequence, this sequence can be written, can be modified now as you see here. The first one is here 1 by 3, 2 to the power n minus 2, minus 1 by 2 to the power n, and here 1 by 3, 2 to the power n minus 1 by 2 to the power n, and this stands for n, for those n, for even n. So n equals to 0, n is even, and the second one is also n equals to, n is greater than 0, n is, but this time n is an odd number, n is odd. Now we have to observe this, and you see this in the question, 1 by m equals to 1, here n equals to 1 to m, and here is Sn. This means that we have to find S1 plus S2 plus Sm by m, this m. Now we are going to use Cauchy's theorem on limits, and you know, if Lt n tends to infinity, a1 plus a2 plus an by n, then this is equals to Lt n tends to infinity an. Here if you tend Lt n tends to infinity, then these two Lt n Sn n tends to infinity, if you tend n to infinity, then in both of these cases you are going to get infinity. This you must keep in mind. And now there are two situations, because we have separate function for even and odd n, so we will separate. There will be two cases. Suppose m equals to 2q, an even number, and here case 2 m equals to 2q plus 1, here is odd one. So in this case row m equals to row 2q, and this will be s1 plus s3 plus dot 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 s2q minus 1 by the number of terms 2q, and plus, actually I have separated odd ones and here the even ones, s4 dot 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 s2q by 2q. If you tend the limit, m tends to infinity, this means that q tends to infinity. So lt row m where m tends to infinity, then this will be lt q tends to infinity. Here I am writing here in this case the limits will be lt q tends to infinity 1 by 2 s1 plus s3 plus dot 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 s2q minus 1, and here will be q, plus lt q tends to infinity half s2 plus s4 dot 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 s2q by q. And now we can apply the Cauchy's theorems on limit. You see number of terms is q, and the same thing you see here q. Here also number of terms is q, the same thing you see here. And I have shown that in both of these cases, if you n tends to infinity, then these two will go to infinity. So this will be infinity half into infinity plus half into infinity, and this comes out to be infinity. Now the case number 2 is where m equals to 2q plus 1. In this case row m sigma m equals to 2q plus 1, and this will be s1 plus s2 plus s3 s1 the odd ones s3 s5 dot 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 sq minus 1, and here 2q plus 1 plus, now write the or even terms s2 s4 dot 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 s2q, here will be 2q plus 1, and here 2q plus 1. Now this can be modified. You see that this, if you count this, then here will be q plus 1 terms. So to use Cauchy's theorem on limits, we have to write here q plus 1, and so you have to write this q plus 1 to manage, and here it is already 2q plus 1. And here the same way, here you have to write s4 plus dot 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 s2q, and here number of terms is q, so you have to write q, and here to manage we write q, and 2q plus 1 is already here, 2q plus 1. And now let lt m tends to infinity. This means that q, if m tends to infinity, then obviously q will tend to infinity, because here is the relation m equals to 2q plus 1. So this, according to Cauchy's theorem on limit. This will be LT q tends to infinity s 2q plus 1, and here limit of this when q tends to infinity will be half, and this will be LT q tends to infinity. Here will be s 2q, and again the limit of this q tends to will be half, and again this time you see that this will be infinity, because I have already shown that whether it be even or odd, in both cases Sn tends to infinity. So infinity into half plus infinity into half, that is infinity. This means that rho infinity is infinity, so the sequence is divergent, so you are not getting any limit point. So hence the number of, here you see the number of limit points of the sequence will be 0. So this is the right answer. Now this solution is over.